Okay, so we have this question called predecessor and successor, and we need to find out what is the predecessor and successor of a given key. We have the root node of the given binary search tree, and we need to find predecessor and successor. Okay, so let's take an example. What I want to find out the predecessor of 2. Okay, so the predecessor of 2 will be just smaller element than the 2, and the successor of the 2 will be just greater element of the 2. And I'll be creating the function of for finding out the predecessor and successor separately. So let's first check out the predecessor of 2. Here we are. We are at the root node, and it is clearly greater than the 2. So it is surely it is not the predecessor of the 2. So we will move to the left. Here we are at the node 2, and we found out that the 2 is not smaller than the 2, so we will moving to the left. Okay, so here we are. Uh, we will check if the current element is greater than the current answer and uh, is smaller than the key, so we will be using it as our answer. Okay, so initially we will take our predecessor as minus int minimum. We will take our predecessor as int minimum. So because we need to find out the just smaller than element, so we will be comparing the int minimum with the current answer. So here we are. The int minimum is very big number and it is in the range of 2 and minus something. So here we are at the predecessor, and we will still move to the left to in search of next smaller element, and uh, yet next greater element, and yet smaller than the 2, to find out the predecessor of 2, which is closer to the 2. So we'll moving to the right, and we will be looking for the predecessor of 2, which will be greater than 1. So here we are. It is null. Nothing is in the right. So finally, our answer will be the 1. And if we look for the successor, we are here. Here we are. We are at the root node, and we found out that the root node can be our answer because it is smaller than our current answer and yet greater than the 2. So we will move to the left in search of closer element to the 2. Here we are. We need to find out the successor, which is closer to the 2. As we can see, all the elements that are present to the left are smaller, so we will move moving to the right, which will be smaller than 10 and greater than 2. Here we are. We are at the node 5, and 5 is greater than 2 and yet smaller than 10, so it can be our answer, which is successful. And we need to find out the element closer to the 2 and smaller than the 5. So we will be moving to the left. Here we are. We are at the node 3, and we check if 3 is possible successor. So yeah, it is smaller than 5, greater than 2, so it can be the successor. Okay, so we will move to the left in search of yet smaller element closer to the 10 and closer to the 2 and greater than 2. Okay, so here we have nothing, so this will be our successor. So let's create two functions, predecessor and successor. Void predecessor, it will have three arguments, comma, and x. This is what we need to find, and answer, which will be which we will be using by reference because we need to store the final answer in this. Okay, if root equals to null, will simply return, and if root key root key is smaller than x, and then root key is greater than root key is greater than answer key, then answer will be equals to root. Okay, now we have two things. If root key is the x, smaller than the x, we need to find out its we need to find out a element which is greater than the root and closer to the x. So we will be moving out to the right. 3 root right x answer. Similarly, if root key is greater than or equal to x, root key is equals to x. We need to find out predecessor, so we'll be going to the left. Root key is greater than the x. So we need to find out the predecessor, so we will be going to the left. So let's write left here. Okay. So yeah, we are done with our predecessor. Let's create a successor. Successor, let's call it successor. Root key. Root key is greater than x. We will be moving. A root key is greater than x. Yeah, and root key is smaller than answer key. Then answer is equals to root. If root key is smaller than x, root key is smaller than x. That means we need, let's suppose our key is 5 and we are at the 2, and we need to find the successor of 5. So, in search of that key, we will be moving to the right. So, yeah, root key is smaller than the value. So, we will move over to the right. And let's suppose our key is 2 and we need to find out the successor of 2. So here we are at the key and we need to find out its next data. So we will be moving to the right. So if root key root key is smaller than or equals to x, moving to the right. If root key is greater than, like let's suppose I want to find out the successor of 2. It is greater than 2, so we need to find out its successor, so we will be moving to the left. Okay, yeah, I think I have done all the things. Let's change its successor. Okay, let's call them P successor. Okay, P is equals to predecessor is equals to int 3 root P P S P S is equals to If let's run the function, check have we made any problem. Ah, it is working absolutely fine. Okay.